Hello and welcome to Learn Data. It's great to have you on this channel. I'm Nilesh, and in this video, we'll learn about model selection methods. So, we'll talk about cross validation and how we can evaluate performance of an estimator using cross validation methods. And this is the outline of the topics that we'll be covering in this video. If the video becomes too long, I'll cut it into maybe or two or three parts. So, let's get started. One of the common mistakes while training model is training the model on the entire data set. So entire data set is used as a train set rather than splitting it into a train and test set. So this uh, if if the model is trained on the entire data set as a train data set, then it can lead to overfitting. So if you have a new data point that comes in that you need to say classify using the model that you've created, then that model would not be able to give you the correct answer because the model may overfit on the trained data set, and that's one of the mistakes that can be avoided. And to one of the ways to do that is simple way to do that is creating a test data. So you have your original data set. Say let's say if you have 100 records, you could split that and maybe you could put 60 records for the train set. You can train the model on that, and if you're satisfied with the model, then you can use the test set, which could be 40 records, and you can look at the predictions and see how accurate the predictions are, and then that would be your accuracy score for that model. Now, is there a problem there? There is. So one of the problems is if you have a trained data, and if you're creating a model, training a model based on the trained data, and now if there is a test data that is used to check how well the model performs on an unseen data set, then let's say you have created a model, now you have this test data set that you can try and check, and you get an accuracy of say 80%. Now what the next step you could do is you'll probably go ahead and change some parameters in the model, retrain the model, and then again, if you'll be wanting to check the accuracy of that model. So what the next step would be, then again use the same test data with the model that is now revised and check the accuracy. Now let's say the accuracy comes down, goes up to 92%, and if you iterate through that process, you may get a model that gives you 99% accuracy after a couple of iterations with the test data that you have. But the problem there is the test data could be leaking the knowledge the into your trained data set, and by that I mean is repeatedly using the test data is not good if you're training model. So test data has to be separate. It um, so it has to be separate. So after the model is run, done everything, only after that you can use the test data. So as to avoid the issue of data leakage into the model that you are trying to create, and to avoid that, there is another way you can do this is instead of creating just one test data set, you could create two of them. So, and rename the second one as a validation data set. So here now we have a train data, validation data, test data. So out of 100 records, let's say 60 go for train set, 20 go for validation set, and then we have 20 that go for the test set. So now when you train the model on the train data set, you can test it on the validation set. So with this approach, the actual test data is completely separated and untouched while you are retraining the model and optimizing the parameters until you get the accuracy or MAC if you are doing regression that you are satisfied with. And so that's the advantage of using a validation data set. So this would potentially avoid the issue of uh, data leak into the test data, because the test data is never seen by the model. So the approach here then is you retrain the model until you are satisfied with the output score, and then once the model is final, only after that we want to run that model on the test data set to get your predictions, and that would be your final score and final score on the unseen data. So if you were to put that model into into production, then you could expect that score as the model is working in production. Now, is there a limitation to using a validation set? And yes, there is. So if you have small data set, this could be an issue, because you the data set is split into three parts, and here we have train, validation, and test. So you may have less number of samples for the validation set. That's one issue. And additionally, there could be another issue, which is that the results can depend on the random choice between the train and validation set. So what records are chosen between those two? And so to counter that, there is yet another method which is called cross validation, or CV for short. So in this case, what we want to do is, first of all, one of the advantages of using this cross validation method is that there is no need to put a separate validation data set aside for training a model. So ideally, what you'd be doing is, you have, let's say, 100 records, you can split that into train and test data, and the test data then will be untouched by the model until it is trained completely. And then for the trained data set, will be used for both training and testing. It does both the jobs in that particular set. And the way that works is the trained data is split into sections. So here I'm showing 1, 2, 3, 4, 5 different sets within the trained data, and one of those sets we set it aside as a test data, and the remaining 4 would be used for training the model. So you train the model on the green folds. These are also called folds. So these folds, and then once the model is trained, you can test it on the remaining set within that particular split, and then you iterate through this process. So if you specify cross validation equals 5, then you have these 5 splits, and the data is the model is trained on different parts of the trained data and tested on different parts of the trained data in each iteration, where in each iteration uh, split is used. So first iteration split 1 is used, second iteration split 2 is used, and so on. And finally, once the model is done going through the entire train set, then the scores are averaged, and that is the score, that's the validation score you have. And if you are satisfied with that score, then you can go ahead and consider the model as final and run the test data in it. If you are not satisfied, you can tweak the parameters again and rerun the cross validation on the trained data set until you are satisfied with the final score. So once the model is ready, then as before, you can run the test data on it and see what the predictions are, what the score is on the unseen data set. Now, uh, the entire video focuses on cross validation. So there are different methods by which the data can be split, and each of these methods have uh, different usages. So we will walk through each of those and how it works. So before getting into that, let's look at what is how do we measure the scores during cross validation. So one method in scikit-learn is cross underscore val underscore score, and within parentheses you specify the classifier, the values for x and y, and then number of times the splits need to be done. So here CV is equal to 5, so there will be 5 iterations. So this is one way. The second way is you can one can specify scoring is equal to, and here you can specify the string for getting the score. Additionally, if we are using shuffle split, we'll go through what shuffle split is in a few minutes. So shuffle split is the data set is shuffled and then split into different folds or different sets to be used for cross validation. So to be used for CV, and that's what is done here. Here we can specify the test size, so that is the test site within each of those splits, and that can be entered here in the cross-val score. So you have a randomized uh, train and test set, train and validation set that is provided for the cross-val in each iteration, and finally you'll get the average scores after all the splits are run. Next, there is also a provision for using a customized uh, s- customized split. So if there is a specific way in which you need the data to be split for cross validation, then there is a function called custom underscore cv underscore folds in scikit-learn. You can use that, and then that can be input here. So there is a typo here. It should be cv underscore no, I think that's good. So custom underscore cv, so that goes as an input to the cross-val score, and uh, that will give you the scores after the cross validation is performed on the train data. So by default, cross validation uses k-fold methods and stratified k-fold to create the folds. And we'll look at each of those in upcoming slides. Now, before moving on, there's one very, very important point to note, and that is the data transformation that is done on the train set and test set. There's a way you want to do it. So let's say if you are using a standard scaler, so the standard scaler needs to be fit only on the train set and not on the test set. So as you can see here, we have the standard scaler which is fit on the train set, and then we use the same fit. So that is, we use the same coefficients that were created while fitting the standard scaler on the train set for both train and test set transformation. So here we have x train transformed, and that uses the same scaler that was used to fit train, and for x test as well we use the same scaler that was used on uh, fitting on train to transform the test dataset. So that's one way. There's another way in which you can simply use a pipeline. So here we have sklearn.pipeline, and within pipeline you can specify the method for scaling. So here it is a standard scaler, then you have the classifier. So when using the cross-val score, we can use this pipeline as a classifier here to perform the cross validation. So now this particular pipeline can do everything. It can do the scaling, it can do cross validation, and it'll give the cross validation score for the classifier SVC. Yes. So apart from cross val that we have looked so far, is there anything else with scikit-learn that we can use to uh, get the score of a cross validation process? So there is, and it is called cross underscore validate. The difference between those two is that cross val score allows one metric, whereas cross validate allows multiple metrics, as well as it gives fit time, score time, and can give scores for both train and test. Here is an example of how cross-validate can be used. Similar to cross-val score, we input classifier x, y, and for scoring, we can specify scoring is equal to scoring, which could be input in different ways. It could be a list, dictionary, or it could be a single metric. So list would be just strings, comma separated. Dictionary, it will have a key, and then we have the string for that particular metric. Additionally, we can also use a custom scoring methods by using make scorer. So we can use that in the dictionary, and then the entire dictionary can be input to cross-validate to calculate all the scores in each iteration of the cross-validation process. Additionally, we can also specify just a single string for the metric. Now, when using, now these are the examples where we are going to look at some code on how to use a list, dictionaries, etc. for cross-validate. So here, as you can see, for scoring, we have precision underscore macro, recall underscore macro. That is used as an input to cross-validate, that is shown here. And as you can see, the scores variable stores all the information, and within scores, then we can get the fit time, score time, test, and as well as the metrics that we asked it to find for us. And then for each of the scores, we can uh, specify scores and then uh, square brackets and the string within it to get the array of scores that were found during cross validation. Similar to list, we can specify dictionary. So here we have a dictionary with that we saw earlier, which has two different metrics, precision underscore macro, and then other one is using make underscore scorer. So both of these can be input to cross validate. Now, one additional change in this particular code is that you'll see return underscore train underscore score is specified as true. What that does is, if you are interested in finding what is the train score, then by specifying that as true, the scores variable will have that data, so you can pull that later on. Like here, scores train underscore rec underscore macro will give the scores for the train. And if there is a single metric, it's straightforward, as we can see here, similar to cross-val score. This can be used to get values for the score, values for the metric, as well as this will return fit time, score time also. Now, for obtaining predictions by cross validation, there is another method, cross-val predict. What cross-val predict does is it returns the score for each item of input. So this can be memory intensive. If you need this in score for each item, then you can get that as well. So far we have looked at cross-val score, cross-validate, and now this is third one, cross-val predict. So there are three powerful methods that you can use to get the score from the cross-validation process. Now, before getting into each of the methods, how the splits are done on the trained data set that is used as the input for cross-validation, let's look at this term i.i.d. What does it mean? Independent, so spelled out, it would be independent and identically distributed data. And the idea here is that if you have different records in your data set, so the idea here is that the data is independent of each record, is independent of each other, and it's not, so the records from the first half are not dependent on the records on the second half. That could be the case uh, if, if it's a different type of experiment, and so that is something to keep in mind, because if you are splitting the train and test data set, then this is the assumption that is used in scikit-learn. And this comes into play if you are trying to do shuffle split, where if there is a continuity, for example, if it's a time series and there has to be a continuity, then you do not want to randomly split the data set because that breaks the continuity of the timeline.